Alright, so continuing on with similar figures and looking at similar triangles a little more today. We got theorem 8.1, which tells us if two polygons are similar, then the ratio of their perimeters is going to be equal to the ratio of the corresponding side lengths. Right? So if I take all the sides and add them together to make the perimeter, and then I make a ratio between the two similar triangles, that ratio should be the same as if I take the two corresponding sides and make a ratio out of them between the two triangles. Right, so if I know the perimeters, that ratio is going to be the same as the individual sides. And we got postulate 25, known as the angle-angle similarity postulate. I'm not sure why it didn't print off this little name for that in your notes, but that's what this postulate actually is, AA, or angle-angle similarity postulate, which basically just tells us that if we know that two angles of one triangle are congruent to two angles of another triangle, then those two triangles are going to be similar triangles. So automatically, if we just know two sides are congruent, that's enough to know that they're similar. And this example, triangle JKL is similar to triangle MNO. Find the value of X. Right, so it tells us that they're similar, so we know automatically that their ratios should be equal to each other. Right, they should be proportional. And so if we take the corresponding sides, so you got 15 and 20 that go together. Right? So I'm going to use the proportion to solve for the missing side. So MO and JL, they're corresponding sides, so we're going to set that as a ratio, 15 to 20. Should be equal to a ratio made by NO and KL. Right? So if NO is 9 and KL is X, and once we got the proportion set, then we know that if we cross multiply, those products are going to be the same. So 15X is going to be equal to 20 times 9. Or 15X is going to equal 180. Divide both sides by 15 to solve for the X. And our missing side is going to be, what is that, 12? So just like when we were finding the proportions or checking to see if they're similar, all those ratios have to be the same. So we can use that fact or that piece of information to solve for a missing side if we know that the two triangles are similar. Any question on that? Set up the proportion, cross multiply, and then solve it as a regular algebra problem. All right. And theorem 8.2, side-side-side similarity theorem. So we have a side-side-side congruence theorem, and this is the side-side-side similarity theorem. So in the congruence theorem, we're looking at all three sides being congruent. In this theorem, we're looking to see that it says if the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. So if all three side lengths in a triangle are proportional, then we know they're similar. Kind of like what we checked on just random polygons, but we also had to make sure that the angles matched up in those polygons. When it's a triangle, once we have all three sides proportional, then that's enough to say that the triangles are similar. And then theorem 8.3, the side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So we're looking at two sets of triangles. They got one set of corresponding angles that are congruent, and then the sides that include those angles, or so side AB and DE, and side AC and side DF, if those corresponding two sides are proportional, or in other words, make a ratio out of AB and DE, and that ratio is the same as AC and DF's ratio, then those two triangles are going to be congruent, or similar. Sorry. All right. And that's all we have left in the notes for today. Questions?